Robert Sapolsky. He's this brilliant neuroscientist, primatologist from Stanford.
Right. And what's amazing about Sapolsky is how he connects the hard science to, society, human nature, the bigger picture. He's got this unique background, too.
Oh, yeah.
Yeah, he spent years out in the field studying baboons, like real field work. But he also does lab research, so he sees it from both sides, the animal behavior angle and the deep neuroscience. Gives him a perspective you don't often find.
That makes sense. So what we're going to do is unpack this whole thing, how everything from like a split-second brain signal all the way back to millions of years of evolution shapes how we act. The mission, really, is to give you a shortcut through all this complexity, get you the core insights.
Prepare for some surprises, definitely. There are these connections Sapolsky makes that they really make you stop and think. Might shift how you see things.
Yeah, those aha moments.
Exactly. But his main point right from the start is that human behavior is it's complicated. There's never just one single reason.
No magic bullet explanation.
Nope. You have to look at it in layers. Lots of layers. Not just what someone did, but why, and crucially, in what context. That context part is key.
Okay, so let's dive in. Sapolsky starts with this really provocative story from his own life, a childhood fantasy.
As the Hitler
one. He imagined capturing Hitler, like overpowering guards, bursting in, wrestling the gun away.
The whole action hero thing.
Totally.
Yeah.
Arresting him for crimes against humanity. But then the fantasy turns dark. Really dark. This like visceral urge for extreme punishment kicks in.
Yeah, stuff like blinding him, injecting him with cancer.
Horrific. It's disturbing. And what makes it powerful is how he contrasts that raw feeling with his adult self. His adult self who intellectually doesn't believe in souls or evil or even punishment, really.
It cuts right to that core contradiction in us, doesn't it?
It really does. We say we hate violence, but, well, when it's the right kind of violence done for us.
We often love it.
We do. We watch it, celebrate it, give out medals. We even vote for people who are good at it sometimes or are drawn to them. It's weird.
Sapolsky calls humans extraordinarily weird about violence. Sometimes it's just basic primate stuff, physical aggression.
Right.
But other times, it's pulling a trigger, signing an order, looking the other way, passive aggression. It takes so many forms, some needing almost no physical effort.
And he gives this example. One of the strangest things he says he ever heard about violence.
Yeah.
From the Indonesian massacres in the 60s.
Yeah, the gamelan orchestras. That's chilling.
Right. These death squads killing hundreds of thousands. Sometimes they'd bring traditional gamelan orchestras with them to the villages they were about to destroy.
And when asked why bring music to a massacre? The answer was,
to make it more beautiful.
Just let that sink in. To make it more beautiful. No other animal, Sapolsky says, could even think of that. That's uniquely, terrifyingly human.
And that slams us right into the biggest paradox, doesn't it?
Yeah.
This same species capable of that is also the most altruistic, the most cooperative, the most empathic species on the planet. And maybe, just maybe, we're getting better at it.
It seems like it sometimes. Extending empathy in ways we never used to. Lots of things in the last century seem to have helped that along.
So the huge question is, how do we make sense of the biology behind both sides of that coin? Our best and our worst.
It has to be about looking at all those different layers of influence. No other way.
Exactly.
Yeah.
And that's Sapolsky's whole approach. To understand why a behavior just happened, you need to ask that question across different timescales.
Right, because it's never just one thing, not one brain region, not one hormone, not one gene doing it all on its own.
And context changes everything.
Yeah. Everything. Pulling a trigger could be murder or heroism. Touching someone's arm could be comfort or betrayal. Same action, totally different meaning depending on the context.
1 second before brain activity.
Okay, let's start right before the action, that crucial second in the brain. The amygdala often comes up first with aggression. Right?
It does. For a long time, that was the main story. Stimulate it, you get aggression. Damage it, aggression disappears. But it's deeper than that.
How so?
Most neuroscientists now would say the amygdala is fundamentally about fear, phobias, learning what to fear. That's its core job.
Oh.
You really can't get the biology of violence without understanding the biology of fear. Sapolsky says if no amygdala neuron ever had reason to be afraid, you'd probably see, lions and lambs sleeping together more often.
Wow. And it's fast, right? The amygdala.
Incredibly fast. It gets sensory info through a shortcut. It knows you might be looking at a snake before your visual cortex, the conscious part, has even fully processed the image.
That sounds useful.
It is. Speed is good for survival.
Yeah.
But it's sloppy, prone to errors. That's how you get tragic mistakes, like mistaking a phone for a gun. The info is privileged, gets there first, but it's not always accurate.
Okay, what else is firing in that split second? The insula.
Right, the insular cortex. In most animals, it's about gut feelings, literally.
Yeah.
Taste, disgust. You bite rotten food, insula fires, you gag, keeps you from getting poisoned.
Makes sense.
But in humans, it does something extra. It fires not just from bad tastes, but from thoughts about bad tastes. And even more importantly, from moral disgust.
Whoa.
Yeah, we feel sick to our stomachs about things we find morally wrong. That ancient wiring for physical disgust got sort of hijacked for abstract moral judgments.
But that sounds potentially problematic. Moral disgust isn't universal.
Exactly, it's a moving target. What disgusts one person or one culture is totally normal to another. Relying on that gut feeling of, yuck, that's just wrong, the wisdom of repugnance can lead to some really bad moral calls, and the insula shouts this disgust news straight to the amygdala.
Okay, amygdala for fear, insula for disgust. What about the frontal cortex, the thinking part?
The frontal cortex. Sapolsky calls it the most interesting part of the brain, its main job. It makes you do the harder thing when it's the right thing to do.
So like self-control, resisting temptation.
Exactly. Impulse control, delaying gratification, managing emotions. It's the brain's CEO, basically.
And how does it interact with the amygdala?
It's constantly trying to put the brakes on, sending signals down, saying, whoa there, buddy, maybe don't do that. Think about the consequences.
Top-down control.
Mostly. But it's a two-way street. Those strong gut feelings from the amygdala and insula, they bubble up and influence the frontal cortex too. Think about making a decision when you're really worked up, seems brilliant at the time.
And you regret it later, yeah.
That's the bottom-up influence. So the frontal cortex isn't just this cold, rational calculator. It's marinating, as Sapolsky puts it, and all that visceral stuff.
And it's involved in both good and bad behavior.
Absolutely. It helps you resist the urge to lie. But if you decide to lie, it also helps you do it convincingly. Maintain eye contact, keep your story straight. It's about executing the chosen plan, whatever that plan is.
Complex. Okay, what about dopamine? That's reward.
It is, but it's even more about the anticipation of reward.
Yeah.
The wanting, the seeking. It drives goal-directed behavior.
Oh.
And it goes wild for uncertainty. Intermittent reinforcement, the power of maybe. That's why slot machines are so addictive.
The possibility of reward keeps you hooked.
Totally. Nothing fuels dopamine like maybe. And interestingly, that same system lights up when we punish people who break social rules. There's a reward anticipation there too.
Huh. And finally, you mentioned face recognition and empathy areas, fusiform cortex and anterior cingulate.
Yeah, but with a crucial catch. On average, they fire less strongly for faces or pain belonging to people of a different race.
Seriously?
It raises that critical question. Whose face? Whose pain? Our basic empathic and recognition circuits seem to have this built-in qualifier based on us versus them.
Seconds to minutes before. Sensory information.
Okay, so that's the instant before. What about the seconds or minutes leading up? Sensory stuff from the environment.
Huge influence. Stuff we're often not even aware of is constantly nudging our behavior.
Like what? Give me some examples.
Okay, remember the amygdala firing differently for faces of other races? That happens in 1/10 of a second.
Yeah, the potential innate racism thing.
Right, but here's the twist. Show a baseball fan a picture of someone wearing a rival team's cap. And their amygdala fires up, regardless of the person's race. But show them someone of a different race wearing their own team's cap. No amygdala reaction.
So it's not about race at all, it's about the team. The US versus them category.
Exactly. Sapolsky is adamant. The idea of innate human racism. It's completely unfounded. It's incredibly easy to shift who we see as us and who we see as them. A baseball cap can do it.
Wow, that's surprisingly simple.
And there's more. Susan Fisk's work at Princeton. Just ask someone to look at a face from a different group and think about something totally random like, do they like broccoli?
Okay.
That simple act of thinking about them as an individual, even in that trivial way, makes the amygdala's us-them response disappear in seconds, because you're seeing a person, not a category.
That's powerful. So these categories are really fluid.
Highly malleable. And other things too, like put up a picture of eyes at a bus stop. People litter less, cheat less on stuff, give more to charity. That feeling of being watched.
Subliminal cues.
Totally. Or give someone gross-tasting cod liver oil. For a few minutes, they become more judgmental about other people breaking rules. They confuse the bad taste with a bad act.
That's bizarre.
Isn't it? Or put someone in a room with a hidden stinky garbage can while they fill out a political survey. They become more socially conservative, not economically, just socially. The bad smell triggers that moral disgust thing.
Unbelievable. What else?
Have people sit in a hard wooden chair versus a comfy one while evaluating job candidates. The ones in the hard chair rate the candidates as more rigid, more inflexible.
We're just puppets of our environment.
It feels like it sometimes, and maybe the most stunning one. Parole decisions. A huge study looked at thousands of cases. The biggest predictor of getting parole.
What?
How long it had been since the judge ate lunch.
You're kidding.
Nope. Right after a meal, like a 60% chance of parole. 4 hours later, basically zero.
Why?
Because that hard thinking, weighing circumstances, empathy, nuance, that takes frontal cortex energy. And the frontal cortex runs on glucose. When blood sugar drops, it takes the easy route, deny parole. And the judges, they'd never say it was because they were hungry. They'd give perfectly rational sounding legal reasons.
That is deeply unsettling.
It shows how much these hidden factors influence us constantly, and how easily our us versus them lines can be redrawn.
Hours to days before.
Hormones. Okay, let's zoom out a bit more. Hours to days before. Hormones. Testosterone has to be first on the list for aggression.
It always comes up, yeah. But Sapolsky really pushes back on the simple idea that testosterone causes aggression. He says it doesn't invent it.
What does it do then?
It exaggerates existing social patterns of aggression. His baboon example is great. Inject a baboon with testosterone. It becomes more aggressive, but only towards baboons lower in the hierarchy. It doesn't suddenly start picking fights with the alpha male.
Ah, so it amplifies the aggression they were already likely to show.
Exactly. And in humans, it's even more nuanced. Testosterone basically makes you do whatever you need to do to gain and maintain status.
Whatever that takes in your particular world.
Right. So if in your world, you get status points for being generous. Testosterone can actually make you more generous. He jokes about injecting Buddhist monks.
They'd run around doing random acts of kindness. I remember that.
Yeah. So the problem isn't testosterone itself. It's that our society rewards aggression with status so damn easily.
That's a really important distinction. Okay, what about the nice hormone oxytocin? Bonding, trust.
The cuddle hormone, yeah. Again, Sapolsky says it does no such thing. Not universally, anyway.
Okay, challenge my assumptions again.
He points to studies using that classic runaway trolley dilemma. Give people oxytocin.
They become nicer, save more people?
Not quite.
Yeah.
In a Dutch study, oxytocin made people more likely to save someone with a typically Dutch name, like Dirk. But they became more likely to sacrifice someone with a German name or a Muslim name.
Whoa, so it boosts in-group favoritism.
Precisely. Oxytocin doesn't make us nicer overall, it makes us nicer to us. And simultaneously, kind of crappier and more suspicious of them.
So hormones aren't simple on-off switches for behavior?
Not at all. They modulate things. They tweak the volume knobs on existing tendencies, depending heavily on the social context and who we perceive as us or them. Much subtler than we usually think.
Weeks to months before brain changes.
All right, zooming out further. Weeks, months. The brain itself changes, right? Neuroplasticity.
Yeah, the brain is constantly remodeling. Neurons make new connections, prune old ones. Areas can grow or shrink based on experience. We even grow new neurons in some areas as adults.
That sounds hopeful, like we can always change and learn.
It is, but with caveats. Neuroplasticity isn't magic. It won't suddenly make you a concert pianist or fix a major injury overnight. And crucially, it's value-free.
Meaning
Meaning it can make you better at compassion and empathy, sure, but it can also make you, as Sapolsky starkly puts it, better at ethnically cleansing villages. It just makes the brain better at whatever it's repeatedly doing. Adaptation, not morality.
Adolescence, childhood, fetal life.
Okay, let's go way back. Development. Adolescence first.
Yeah.
Why are teenagers? Well, teenagers.
Sapolsky boils it down to two key things. First, your dopamine system, the reward-seeking part, is going full blast by puberty, like fully mature.
Pedal to the metal.
Right. But second, your frontal cortex, the brakes, the impulse control center, it's still under construction, seriously underdeveloped until your mid-20s.
Ah, lots of gas, not much brake.
Exactly. Explains a lot, right? The impulsivity, the risk-taking, the huge importance of peers, teenagers, often define themselves by how others see them, because that frontal cortex sense of self isn't fully formed yet.
Makes sense. And that period shapes the adult brain.
Massively.
Yeah.
Especially the frontal cortex. Because it finishes developing last, it's the part of the brain least constrained by genes and most shaped by experience. You need those years to learn all the complicated context-dependent social rules, like when is it okay to lie, how does status work. You don't get that from DNA. You learn it.
And even earlier, Childhood.
Absolutely crucial. Childhood matters. Different experiences literally build different brains. Stressful childhoods, nurturing childhoods, they lead to different adult frontal cortexes, different amygdala sensitivities.
And this connects to epigenetics, that idea that experience can change genes.
Well, not change the genes themselves, but change how they're regulated.
Yeah.
Whether they get turned on or off. That's epigenetics.
Give me the rat example. That one's amazing.
Right. So some rat mothers are naturally very attentive. Lots of licking and grooming of their pups.
Okay.
Pups who get that high level of grooming. It triggers an epigenetic change in their brain related to stress hormones. As adults, they release less stress hormone. They're calmer.
And the punchline.
Because they're calmer, with lower stress hormones, when they become mothers, they are more likely to lick and groom their own pups. The attentive mothering style gets passed down, not through genes from mothering, but through the experience of being mothered, which changes gene regulation.
That's incredible. Passed down through behavior and its effect on genes.
Exactly. And it even starts before birth. A mother experiencing high stress during pregnancy. The fetus is bathed in those stress hormones. That causes epigenetic changes in the fetus's brain, leading to an adult with a bigger, more reactive amygdala, higher stress levels, who might then pass that on if they get pregnant under stress. It can ripple across generations.
So the environment, starting from the womb, is sculpting our biology in ways that can last a lifetime, even generations.
That's the power of it.
Yeah. Fertilized egg genes.
Which brings us finally to genes themselves, the fertilized egg. There was that period, maybe still is, where everyone thought genes explained everything.
The hysterically giddy period about genetics, Sapolsky calls it, but he argues pretty strongly against genetic determinism. He says genes have no idea what they're doing.
Meaning they're not a fixed blueprint.
Right. Genes don't operate in a vacuum. They're constantly being turned on or off, dialed up or down by the environment. The environment inside the cell, the environment in the body, like hormone levels, and the environment out in the world.
So the same gene can do different things depending on the context.
Totally. His go-to example is the MAO alpha gene variant linked to aggression. A huge study showed it only increases the risk of aggression if the person was also abused as a child.
Only if.
Only if. If you have that gene variant but weren't abused, zero effect. Absolutely none.
So it's not the gene or the childhood abuse alone.
It's the interaction. Always the interaction. You can't ask what a gene does, only what it does in a particular environment. Genes decide nothing on their own.
And for humans, this interaction is maybe even more important.
Way more. Because we live in such an insane variety of environments compared to any other species, from deserts to rainforests to cities to suburbs, our environments are constantly tweaking how our genes get expressed. We are, in a way, freer from our genes than any other animal.
Ancestral culture and ecosystems.
Okay, let's keep zooming out. Beyond genes, to the cultures and even the ecosystems our ancestors lived in. How does that reach us today?
It shapes culture in deep ways. Like, statistically, people whose ancestors lived in deserts were more likely to invent monotheistic religions. Rainforest dwellers, more likely polytheistic. The environment nudges cultural evolution.
And that affects things like our ideas about gods.
Yeah, small hunter-gatherer groups. Their gods usually don't care much about human morality. But when you get large, anonymous societies where reputation is harder to track, that's when moralizing high gods tend to emerge.
Gods who are watching you, judging you.
Exactly. They become that pair of eyes on the bus stop, a supernatural enforcer of social norms when face-to-face accountability isn't enough anymore.
Fascinating. What about livelihoods, like herders versus farmers?
Big difference. Pastoralists, herders are always vulnerable. Someone can steal their entire wealth overnight, so almost universally they developed cultures of honor.
Meaning?
Intense focus on reputation, swift and often violent retaliation for insults or theft. Warrior classes, long-running feuds or vendettas. It's a cultural adaptation to that specific economic vulnerability.
And this stuff shapes us from birth.
Literally minutes after birth. Studies show babies born into these cultures of honor. Mothers talk to them louder, hold them for shorter periods right away. In collectivist farming cultures, mothers tend to nurse newborns for longer in the first week.
Wow. Culture shapes parenting right out of the gate.
It's this continuous loop. Ecosystems shape cultures, shape brains, shape behaviors. And you see the differences immediately. Brains, bodies, culture, genes, they're all co-evolving.
Millions of years of evolution.
Which finally brings us to the deepest layer. Millions of years of evolution. We're talking about how behaviors themselves evolved. Not just survival of the fittest, right? It's about passing on genes.
Exactly. Modern evolutionary theory rests on three main pillars for explaining behavior. First, Individual selection, doing things that maximize the copies of your genes going into the next generation.
Like Genghis Khan.
The ultimate, if rather extreme, example. Yeah. Second, kin selection, helping your relatives reproduce because they share copies of your genes. Humans do this in unique ways, like with inheritance.
Passing down wealth helps relatives pass on genes. Makes sense.
And third, reciprocal altruism, cooperating with non-relatives with the expectation they'll return the favor later. Basis of trade, economics, all that. Very developed in humans.
Okay, individual, kin, reciprocity. That covers a lot.
Yeah.
But does it cover everything humans do?
That's the really interesting part. Sapolsky points out behaviors that don't quite fit those molds, things that seem uniquely human. Think about groups like the Shakers, who were celibate. They consciously chose not to pass on their genes. Or adopting children you're not related to, pouring resources into them.
That doesn't fit kin selection.
Nope. Or even just holding a door open for a stranger in an airport you'll never visit again. There's zero chance of reciprocity there.
Why do we do that?
That's the profound question. These acts, these moments of seemingly illogical altruism that go beyond direct genetic benefit or expected payback. Sapolsky argues they really define us. They show a capacity that stretches the standard evolutionary explanations.
So after going through all these layers, from the split second before, back through hormones, childhood, genes, culture, evolution, the big takeaway is definitely
complicated. Insanely complicated.
Yeah. Which leads to Sapolsky's warning, right?
Yeah. Be really, really careful before you think you truly understand why someone did something, especially if it's something you judge harshly. There's just so much going on beneath the surface.
But here's the crucial twist, the hopeful part.
Right. None of this stuff is set in stone.
All those factors we talked about, ecosystems, cultures, even our brains, they change. Sometimes dramatically.
And he gives these incredibly powerful examples of human transformation, people changing in ways you'd never predict.
Like John Newton.
Yeah. Captain of a slave ship, invested in the slave trade. Horrific stuff. Then undergoes this massive change, becomes a key figure in abolishing slavery, writes Amazing Grace. How does that happen?
Or the Japanese pilot from Pearl Harbor.
Zenji Abe led the attack. 50 years later, goes back to Pearl Harbor, meets survivors, apologizes profoundly, an immense shift.
And the Christmas truce in World War I, that one always gets me.
Incredible. Soldiers on opposing sides, programmed to hate each other, just stop fighting. They share food, sing carols, play soccer in no man's land.
The whole East versus them thing just dissolved in hours.
It did. Us became the guys freezing in the trenches together, British and German. Them became the officers safe in the back. It took threats from those officers to get them fighting again.
And Hugh Thompson at My Lai.
A U.S. helicopter pilot who saw American troops massacring Vietnamese civilians. He landed his helicopter between the soldiers and the remaining villagers.
And threatened to shoot his own men.
Ordered his gunner to fire on the American troops if they kept killing. He completely redefined us and them in that moment, protecting the victims. Extraordinary courage.
What's so powerful about these stories is these weren't special people. They didn't have different brains or unique genes.
Exactly. They were just like us. And most showed no sign beforehand that they were capable of such radical change.
It hammers home that point about us and them being so easy to manipulate.
For bad, yes, tragically often, but also potentially for incredible good. That capacity for change is in there.
Which leads to Sapolsky's final challenge to us.
Yeah.
His big takeaway thought.
Yeah, it's not just about studying history so we don't repeat the bad stuff. We absolutely have to study the history of astonishing human change.
And the science behind it.
The science that helps explain why and how that change happens so we can make it more likely to happen again. Because if we don't,
we're destined not to be able to repeat those amazing moments.
Yeah. That's the real challenge he leaves us with. Hashtag tag tag outro.
Wow. Okay. That was a lot. We really went deep into the complexity today, unpacking all those layers influencing our behavior.
It's daunting how much goes into it. But also, that final message about change, it's hopeful, isn't it? That capacity for transformation, it's part of our biology, too.
It really is. So as you've been listening to all this, what's sticking with you? Did anything shift your perspective on your own choices or how you see the world?
Yeah, what stands out?
It's definitely worth mulling over. Keep that curiosity going. Keep noticing those hidden influences we talked about. They're everywhere.
Absolutely.
Well, thank you for joining us for this very deep dive today.
Thanks for the great conversation.